I've had a lot going on in my life lately. Okay, so this is called an intro to limits. Intro to limits. All right, and if you see something, all right, so they start out with this problem. I don't really like that problem. But they start off with this problem. You're given 24 inches of wire, and you're asked to form a rectangle's area is as large as possible. Okay, where'd that go? So if you were going to make a rectangle, I can make a rectangle on here. Can I? There I go. Okay, and you're given a perimeter, or you have 24 inches of wire with which to construct a rectangle. And you want to make the biggest rectangle possible. So if I call this like W, and this W, then this side, I can relate the perimeter of this L, call these two things L, right? But how could I get L in terms of the width? What do I know about 2L plus 2W? That equals up to 24. And I could solve for one of the variables. I'm going to solve for L. So if I get 2L equals 24 minus 2W, and I divide by 2, I get L equals 12 minus W. You understand that? Now if I want to maximize the area of this thing, I could come up with an expression for the area, which is length times width. So I get 12 minus W times W. You guys understand where that expression came from? 12 minus W times W. So this would give the area of this in terms of just one variable. What shape will this make if I graph it? What shape is that going to make? It's going to make a parabola, and it's going to make a parabola that looks something like that. Okay? The intercepts are going to be at 0 and 12, right? You understand that? Because if I set that equal to 0, I have the intercepts here. But what I'm trying to find is this point right here. Well, looking at the graph, what would that point be right there? 6. Okay? So I could just plug in 6 into my equation, and I would get the area is equal to 12 times 6 minus 6 squared, okay? Which is equal to 72 minus 36, which is equal to 36. So I know if I want to maximize the area, I would make the width equal to 6? Yeah. W equals 6. This equals 6. What would each of these have to be if L equals 12 minus W? 6 and 6. Okay? And so what shape would this actually be? It would be a square, right, if I want to maximize area. But the whole reason they talk about this is because they talk about what is the limit. So this annotation, what is the limit of the area as x goes towards 6? Or in other words, the limit as x approaches 6 of not x, it should be W. As my Moby board froze. Everything's wrong, okay? As W goes to 6 of 12W minus W squared, that comes out to be 36. And the way we find a limit is by looking what happens to the y value as you get closer and closer to some x value. Okay, so you might plug in numbers in your calculator, because a lot of times you can't do it like graphically like that, or this is very simple to do algebraically. But when you're looking at limits, you're looking at what happens to like if I plugged in 5.9 or something, I would get a number very close to 36. If I plugged in 6.1, I would get a number closer to 36. If I got closer to 6, like 5.999, I would get closer and closer to 36. And that point where you reach as you get closer and closer to some x value, what is the y value that you're approaching? And that's called a limit, all right? And so they just kind of give this as an example of when you might want to find a limit, but this is the notation that you use for a limit. The limit is, I'll write the definition of a limit from your book, which is right here. The limit, if f of x, I have this in my notes that I wrote, if f of x becomes arbitrarily, I don't know how to spell that, arbitrarily, oh, I can look in the book, close to some number L, as x gets close to some number C, then the limit of f of x as x goes to C is L, okay? And you write that the limit of f of x as x goes to C equals L, okay? So for some arbitrary function, like we have some function that's going up and down like this, and you can find a limit anywhere on a function. So if this is some point C, and x is any arbitrary x value, as you get closer and closer to C, you're going to get closer and closer to some value for L over there. So as I get closer and closer to this x value, I'm going to get closer and closer to some y value. Okay, and that's what a limit is. Okay? And sometimes, like with a polynomial function like this, oh, I'm sorry. Maybe that's someone telling me where my notes are. I have to decline this. I'm sorry. It's probably a solicitor. I'm sorry. Okay. Sorry. So anyway, so that's that. Okay. So if you want to find the limits, I have to undo that because my. So let's find the limit. Can you go to the bathroom? The limit as x, sure. I didn't answer your question. 3x minus 2. Okay?
Wait, did you rate
What?
Did you rate?
I want to find the limit of 3x minus 2 as x goes to 2. So one way you can do this is by plugging numbers into your calculator. And you will have to do this in your homework. So I know this is pretty obvious problem because it's a linear function and you could just plug in the number. But I want to show you what I mean by you always in front. I'm going to go like this. So say I have I plug in the function y equals clear 3x minus 2. Oh, mode. I want to be in function mode, right? So say we have y equals clear y equals 3x minus 2, okay? And I want to see what happens as I get very close to 2. So I could go to second table set. You will probably want to do this with your calculators. And keep it on ask, okay? So when you go to your calculator, when you're doing these limits, numerical limits with your calculator, set it to ask because you want to plug in numbers. So then we're going to go to second table. And then we're going to plug in some numbers. When x gets very close to 2, well, what would be a number close to 2 on the left side of 2? On the left side. So what I'm looking at is a graph, y equals 3x minus 2, which is kind of like this. And I want to know what y value I'm approaching as I get closer and closer to 2. Well, yeah, I could plug in 1.9, and I get out 3.7. If I get even closer to 2, like 1.99, I get out 3.997. If I come from the right side towards 2, like 2.1, I get out 4.3. What's even closer to 2 on the right side? 2.01. So if I plug in 2.01, I get out 4.03. What number does it look like I'm getting close to as I get close to 2 in the x? What number is this getting close to? And I can check that out by plugging in numbers even closer to 2, 2.0001, like something like that.
Why can't you just plug in 2?
And I should get, aha! Why can't I just plug in 2? I can, okay? But for a lot of functions, you can't just plug in 2. For instance, what if I want to look at the function y equals sine of x, sine of x divided by x, okay? And I want to find the limit of this. Find the limit of sine of x over x as x goes to 0. What happens as x goes to 0? What happens if I plug in 0 in here and 0 in here? I get 0 over 0, which is called indeterminate. You can't tell anything about it, okay? And actually, if you graph y equals sine of x over x, it kind of looks like, how does it look? Kind of looks like this, and it goes like this, something like that. And it actually, right at 0, it has a hole in the graph. But if you take numbers very close to 0, okay, second table, okay, and I plug in numbers, whoops, I didn't want to do the graph. Second table, where'd it go? It's still trying to graph this. Second, quit. Second table, and I plug in numbers very close to 0, like 0.01, okay? I get out 0.01. Y equals, I want to be in radian. Let's change this to radian. If I plug in numbers very close to 0, like 0.01, I get this number, 0.998. If I plug in 0, I get error. Okay, so I don't know what the limit is, so I have to take numbers very close. What would be a number very close to the left side of 0? Negative 0.001 or something like that. So what, oh, this gives me an exact answer because it's rounding off, but that's not the, oh, it's not exactly 1, but it's very close to 1. So the limit of this function as you approach 0, even though it's undefined at 0, is equal to 1, okay? So sometimes you can't just plug things in and get the answer, all right? Same thing for this. Say I have, I was going to do this example anyway. What's the limit of, limit as x goes to 0 of x over the square root of x plus 1 minus 1? Like that. What if I plug in 0 in here? What do I get? What do I get out? What goes in the, if I were to plug in 0, I get 0 over 0, right? And this is again called the indeterminate determinate, which means you can't tell anything. So what I have to do is actually use my calculator and plug in values. And it turns out if I plug in values, let's go back to my calculator, and we'll try to put this in. Y equals x. Well, it actually ends up being, I'm not going to do it because it'll take too much time. But if I plug in numbers very close to 0, I actually end up getting a number very close to 2. Okay? And so if I plugged in like 0.01 and 0.001 and 0.001, even if I plug in 0, I'm going to get that error again. But if I get very close to 0, I end up getting 2. And algebraically, tomorrow we'll learn algebraic techniques. Hopefully I'll remember my notes for finding limits like that. But right now, and if you look at the graph of this function, okay, it kind of looks like this. It starts here because it can't go lower than -1. And right here, it actually has a hole in the graph at 0. So you're still approaching, this value is equal to y equals 2, right? So even though this hole right here is at 0, 2, okay? Here, why don't I take these away so that you guys could pay attention better, all right? So anyway, so that's how you find limits, okay? Graphically. Find the limit as x. So then we'll have something else that looks like this, all right? Where you have a piecewise function. You guys remember piecewise functions? Maybe? F of x equals, okay, 2, 0, as if x is not equal to 3, and 0 if x equals to 3. If I were to graph this, okay, what I end up getting. So does anyone remember what this looks like? And what if I want to find the limit as x goes to 3? What does this look like?
The line.
It looks like a line. It's a vertical line, and horizontal line, right? And it goes through, we'll change color on it. Okay, it goes through y equals 2. Okay? And so this is like the line y equals 2, except so this says everywhere except for at 3, this thing looks like the line, whoops, not y equals 0, y equals 2. Everywhere except at 3, this thing looks like this line. Right exactly at x equals 3, this thing has a value of 0, okay? So it says everywhere except for 3, this function has a value of 2. Right at 3, it has a value of 0. So what would be the limit of f of x as x goes to 3? Looking at this graph, what value is it approaching from both sides? It's approaching 2. So even though the value of the function is 0 at that point, as I get closer and closer and closer and closer to this point, I get closer and closer and closer to this y value, which is 2. Well, that didn't write very well, okay? Which is equal to 2. Okay? So sometimes with functions like that, you can have a hole in the graph, but you can still have a limit. Okay? What would be the limit of this function? What would be the limit as x goes to 5 of this same function?
Would it still be 2?
It would still be 2, right? Okay. Now we have funky functions that look like this. You ready to see a funky function? Okay. F of x equals the absolute. This is one of my favorite functions. Absolute value of x over x. Anyone know what that function looks like? Make a little table of values. X, y. When x is -1, what's y? -1, right? Because you get -1, make it positive, divide by negative, you get -1. When x is -2, what's y? No.
-1.
It's also -1. When x is -3, what's y? -1. When x is 0, what's y? No.
Undefined.
Undefined, right? When x is 2, what's y? +1. When x is 3, what's y? You guys all see where I'm getting that from? Okay? So this function actually looks like, if I were to graph it, it looks like this going this way. And it looks like this going this way. It's not squiggly like that, okay? And this is 1 and this is -1. What's the limit of f of x as x goes to 0? As I get closer and closer to 0 from this side, what number am I approaching? -1. As I get closer and closer to 0 from this side, what number am I approaching? 1. Okay? So because I'm approaching two different values, you say does not exist. Does not, because I have to approach the same exact value from both
Could you
sides.
say 0 since it's in between?
No, you can't say 0 because it's not approaching 0. 0 is over here. Because remember you're looking for what y value it's approaching? Okay? So it's approaching 1 on this side and -1 on this side, so it's not approaching anything. So it does not exist. Sometimes you write that as DNE. Okay? DNE. How about if you have something like this? What if I have something like this? Y equals 1 over x. Let's do y equals 1 over x minus 3. And I want you to find the limit as x goes to 3 of 1 over x minus 3. What would that, do you guys remember what this graph looks like? What does this graph have at x equals 3?
Undefined.
It has an undefined, but what does it have there? Not a hole. Has an asymptote. Okay? So if I go very close to 3, so if I were to make a little table of values, asymptote, remember asymptotes?
Yeah.
So if I have x, y, and I plug in a number very close to 3 on the right side, by 3.01, I get 1 divided by 0.01. What's that? 100. Isn't it? 1 divided by 0.01? Okay? If I plug in a number even closer to 3, so this is x equals 3 over here, by 3.001. What do I get out? 1,000. Okay? If I plug in a number even closer to 3, like 3.0001, I get out 10,000. Okay? So what's happening is as I get close to 3, this thing is going up like that. Okay? As I get close to 3 from the left side, like 2.99, what number am I going to approach? What's negative 100? Okay? Then over here, if I plug in 2.999, I'm going to get negative 1,000, and so on. So what this function looks like here is this way. Okay? So what do I say about the limit as x goes to 3?
No.
Does not exist. Okay? Okay?
Okay.
And then there's one more case in which the limit does not exist. And that's for something like y equals cosine x over x. So say I say find the limit as x goes to 0 of cosine of x over x. Okay? Well, if I put, what do you guys think that answer is? Oh, that's not what I wanted to do. Cosine, so let's change it to sine of 1 over x. That's what I want. As I get very close to 0 from either side, what kind of number am I going to get here? Right? So I'm going to get if I get very close to 0, I'm going to get a very, what kind of number here? Big or small? Big. This is going to be a big positive or negative, right? So in other words, I would be taking the sign of some very big number. So say, could I do like the sign of 10 million? Could I take the sign of 10 million? Could I take the sign of 10 million?
No.
Yeah. Yes. I'm just going around this unit circle lots and lots of times. But what is that number gonna, what does sign never get bigger than or smaller than? It never gets bigger than 1 or less than -1. So what this function looks like, okay, is it kind of looks like goes up and down, then right as it gets closer, okay, it just oscillates infinitely, and then it kind of starts spreading out over here, okay? So what happens with this function is there is no limit, because as you get closer and closer to 0, this thing gets huge, and it's just oscillating between 0 and -1 really, really, really quickly. Okay, I mean between -1 and +1. And you can see that on the graph if you were to plug it into your calculator. Okay, so that's 3 cases in which you have no limits. Okay, so 3 cases where limit does not exist. And the first case is like that absolute value, the absolute value of x over x. Limit approaches different values. From right and left. Right. And then to limit increases or decreases without bound. I should say without bound as x goes to c. Okay, so in other words, you would have like an asymptote at some point, like that one that we did, like over here. Okay, something like that. This is okay, and 3 is f of x. F of x oscillates. How do you spell that? Knock, knock. Knock, knock.
Resistor.
Oscillate. Oscillate, I'm never going to be on time. Oscillates between 2 fixed values. Between 2 fixed values as x approaches c, as in that one approaches c. So that's like that sine of 1 over x is, or cosine, I think cosine of 1 over x does the same kind of thing. Okay, because cosine also oscillates between -1 and 1. Okay, and then we have all these limit properties. I think I guess I need to write them down. Okay, did you want me to? Is that good? Are we done with this? Pretty good at winging it here. Okay, I'll winger. All right. I'm wingered it. So let B and C be the real numbers, and let N be a positive integer. So these are basic limits. These are called basic limits, and then we have some limit properties. Basic limits. Limit, yeah, there's a lot in this chapter. Limit as x goes to c b equals b. And this is where b is a constant. B is a constant. So in other words, if you have like the limit as x goes to anything 5 of 3, that's just going to be 3. Because this is the line y equals 3, and they're saying what is the limit as x goes to 5 of 3, and that's just 3. Right? So that's number 1, I tell you. The limit, how come when I look this way, my Mobius stops? Number 2, the limit as x goes to c, limit as x goes to c of x is just c. What does that mean? That means I'm looking at the graph of y equals x. What does the graph of y equals x look like? It's just a straight line that goes up this way. And as I approach 5, what's the y value that I'm approaching? 5, right? So that's what this is saying. If I just am taking the limit of x, it's just equal, the x value and the y value are the same thing, okay? The next thing, the limit of a squared or a function raised to a power, the limit of x to the c of x to the n is just x to the is just c to the n power. Okay. So for instance, if I want the limit as x goes to 3 of x to the 4th, that would just be what? 3 to the 4th. Okay, which is just 2781, 243? 243. So you say, well, why don't you just plug in the number, right? But like we've seen, there are functions where you can't just plug in the number, like absolute value functions, rational functions where you have poles and asymptotes and stuff like that. All kinds of trig functions have square root functions. They all have different things going on. But for the most part, if it's a polynomial, or if it's a power function, all you really do is plug the number in, and you'll find the limit, because those are smooth and there's no holes or anything like that in them. So if I have the limit as the nth root of n is just equal to the nth root of c, provided c has to be what? C has to be greater than or equal to 0. All right? C has to be greater than 0?
I thought it's just greater.
It just is greater than, okay? Because you can't take the...
You can.
Yeah, I thought it was 0. Greater than or equal to 0. I thought it was greater. In the book they say it's greater than 0. I might have to think about that more. Okay? Oh my, there's more. So I'm just going to talk about five properties. So these are called the basic.
Wait, is it this n square root of c or just square root of c?
The nth, yeah, it's the nth root of c. So in other words, if I want to take the limit as x goes to 2 of the cube root of 15, or the cube root of x, right? That's just equal to the cube root of 2, right? That's all that's saying. All right? And then we have these limit properties, okay? You done with that? I don't know if you need to write this down. This is pretty kind of, what would you say? Obvious, but they talk about them anyway, okay? If the limit of f of x as x goes to c is equal, as x goes to c is equal to L, and the limit of g of x as x goes to c is equal to k, then these things hold, okay? 1, this is called the scalar multiplet. The limit as x goes to c of b times f of x. So I close that, b times f of x is equal to BL. You understand what that means? Okay. So if I know the limit of some function, f of x, if I know the limit of some function is equal to L, and I take, and the limit of some constant, this is a constant, constant is, all I have to do is multiply that constant times the limit. So in other words, I can take that b and move it outside. And with polynomial functions, this doesn't really matter, but if you had something like find the limit, and I use this example again, as x goes to 0, of 5 sine of x over x, what did I tell you in the very beginning? What's the limit of sine of x over x as x goes to 0? 1. So this would be equal to what? 5, right? Because this, the limit of this as x goes to 0 is equal to 1, and 5 times that would just be 5. You see, so that's a case where you'd actually use that. If it's a polynomial or something, you don't really have to use it. The other thing, 2 limit as x goes to c of f of x plus or minus g of x is just equal to L times k. So if you know this limit and you know this, it should be like this. If you know this limit and this limit, all you have to do is multiply them together. 3 has to do with, add them together. 3 has to do with multiplying together. 4 has to do with dividing them. And 5 has to do with raising them to a power. And you can look in your book at those. I'm not going to write them down. Okay? Just a couple things. But if you did see something like this, limit as x goes to 2 of x squared minus 3x minus 1 over x minus 3. How would I find that limit? How would I find that limit? Yeah, all you have to do is plug it in. And if it works, right? So in this case, you would just get 4 minus 6 minus 1 over 2 minus 3, which is, what's that, negative 2 minus 1? That's negative 3 over negative 1, which would be positive 3. Right? So that answer would be positive 3. But if this is, say this were, I were looking at the limit as x goes to 3, okay, of the same function, what would I have to do? I'd have to plug in numbers close to 3. You see that? Because there's an asymptote in the graph, so I'd have to plug in numbers in my table to figure out what arises. So usually if it's just a polynomial or a simple square root function or a linear function, all you do is you plug the number in. But if it's something that you can't find, then you have to use the table feature on your calculator to figure out what the limit is. Get that? Kind of? Yeah? No? Yeah. Okay, so I'll write down your homework, or I'll find your homework, which is, I think I put that in there last night when I lost my teaching notes. And that is pre-calc advanced. And Chapter 11, Limits and Finals Review. So there it is right there. I think you'll find it easy. And okay, and